Hello students, welcome to today's chemistry class. In today's class we'll be discussing about Charles' law. Now Charles' law is a law that relates volume of a gas V to the temperature T at a constant pressure. Now Charles' law states that the volume of a given mass of a gas is directly proportional to the temperature provided that the pressure is constant. Now, how do we know that we are solving Charles' law? Okay, now when you're given a question and in the parameters you were given volume and temperature only, all right, volume and temperature, you're given initial volume, final volume, initial temperature, final temperature, then you know it is Charles' law. Or you were told that the pressure remained constant or the pressure is kept constant, then it is Charles' law. Let's take a look at some questions. Question 1 says if the volume of a given mass of a gas at 0 degrees Celsius is 29.5 cm cube, what will be the volume of the gas at 15 degrees Celsius given that the pressure remained constant? So from here you were told that the pressure remained constant, so obviously this is marked as Charles' law. So let's write out the parameters. So the first thing is to write out your parameters. So we have V1, which is 29.5 cm cube, and T1 is 0 degrees Celsius. In Charles' law you need to convert the temperature from degrees Celsius to Kelvin. To do that you just add 273 to whatever value you were given in degrees Celsius. So that will give you 0 plus 273, that will give you 273 Kelvin. Your V2 is what you're looking for. You don't know it, and your T2 here is 15 degrees Celsius, so you add 273 to it, that will give you 288 Kelvin. So from here, using the formula for Charles' law, V1 over T1 is equals to V2 over T2. So insert all these parameters. You have 29.5 over your T1, which is 273, which is equal to your V2, you don't know, your T2, which is 288. Now, to get our V2, let's cross multiply. You cross multiply here, becomes V2 times 273 equal to 29.5 times 288. So it becomes V2 273 V2 is equal to 29.5 times 288. Let's use the calculator. That will give us 8,496. So you divide here by 273 and divide here by 273. So when you do that, this cancels this, so your V2 becomes equal to 31.1 cm cube. So the answer here is D. So let's take a look at a question, another question. Question 2 says, according to Charles' law, the volume of a gas becomes 0 at dash. Now so we are trying to look for which of these temperature in degrees Celsius will give us 0 Kelvin. Okay, so we need to convert each and every of them to Kelvin. So whichever give us 0 is our answer. So if you do minus for option A, if you do minus 100 degrees Celsius plus 273, that is going to give us 173 Kelvin. For B, if you do minus 273 plus 273, that will give us 0. Okay, for the next one, if you do minus 373 plus 273, that will give us a minus 100. Then the next one, if you do 0 plus 273, that will give us 273. So this is our answer, which is option B. Let's take a look at this third question. If 30 cm cube of a gas at 50 degrees Celsius is warmed to 80 degrees Celsius at a fixed pressure, what is the fractional increase in volume? Now we're looking for the fractional increase in volume, not just the new volume, but the fractional increase in volume. Now let's write out our parameters first. Our V1 from here is 30 degrees Celsius, and our T1 from here is 50 degrees Celsius. Change that to Kelvin. Our V2 is unknown, and our T2 here is 80 degrees Celsius. Convert to Kelvin. Now V1 over T1 equals to V2 over T2. So substitute in all the parameters you have. This is cm cube, sorry. Now make V2 subject to the formula from here. Your V2 becomes equal to cross multiply this multiplies this, so we have 30 times 353, then divide by this. So using our calculator, so we have our V2 as 32.7. Now, so for the fractional increase, it becomes V2 minus V1 divided by V1. That is equals to so 32.7 minus 30 will give us 2.7 divided by 30. So with our calculator, we have 0.09. So our answer here is D. So there you have it. These are some of the calculations you would come across in Charles' law. So I hope with this video and with the explanation, you've been able to understand what Charles' law is and how to solve. So if you have any questions on Charles' law, please come to the comment section and send, and I will be there to assist. So make sure you share, like, and subscribe for more videos. Thank you.